You know, we've mentioned compounds before, but just as a reminder, what are they? Compounds are when two or more elements bond. And when they bond, they form a compound. You may remember we've talked a lot about the periodic table. So when two or more of these elements bond, we have a compound. And kind of the most common example we have used in class is H2O. You have the combination of two H atoms and one O atom, the two hydrogens and one oxygen here. And that, of course, is a compound. The thing we're going to talk most about is chemical bonds. Chemical bonds are the force that holds a compound together. And you might be surprised to know that the forces that hold a compound together are different for each compound. Some of them are stronger, some of them are weaker. Now, we've mentioned compounds like NaCl, H2O. We've mentioned sugars, C6, H12, O6, for example. These compounds we may have mentioned before, but I want to make sure we mention them now, are always going to have the same formula. Whenever you're talking about water, whether it is found underneath the surface of Mars, whether it is found in the cells of your body, whether it is found in a International Space Station, it's always going to be H2O. It does not have different proportions. We're not talking mixtures here. We're talking about compounds that always have the same proportions. And that's important. Compounds have different strengths of these chemical bonds. Now, it is the solids, and you probably could have guessed some of this. The solids have stronger chemical bonds than the liquids, and the solids have stronger chemical bonds than the liquids, and the liquids have stronger chemical bonds than the gases do. Now, that you probably could have figured out, but what if you have two things that are solid? Two solid compounds. What will be the determining point as to, well, whether this bond is stronger or weaker? The point is going to be the melting point. Any solid that has a higher melting point has a stronger chemical bond than one that has a lower melting point. Say you have one whose melting point is 350 degrees. And of course you may have one whose melting point is 325 degrees. So the one that has the stronger chemical bond is the compound that melts at 350 degrees. So that's going to be the determining factor. In liquid, it's going to be boiling point. The one that has the highest boiling point will be the one that has the stronger chemical bonds than the lower boiling point. So that kind of gives you a little bit of idea about chemical bonds between compounds. Now you're going to end up finding different models of compounds. These are compound models. And you've already seen some in your book. I'm sure you even saw them before you got here. Here is a ball and stick model. Very simplistic. You have, all of these would be the H2O. You have the oxygen here, which is combined with the hydrogen and the hydrogen. These are actually measurable distances here. Now, I know we could just simply draw these, but you actually have distances here that are measurable and angles that are measurable. And it's kind of for a different class, more upper level class than this, but there actually are those. Now, structural formulas look the same, but here's where you have just the written out O's and H's and whatever elements happen to be in that compound. And then you have space-filled models right here. Now, the space-filled models don't account for these angles and these distances. They're more for visual appeal or visual understanding than they are for distances, which for our purposes serves us just fine. Now, it is possible to have bonded ions that are not atoms. Now you remember what an ion is. An ion is whenever you have an electron that flew away from the atom. Let's say we have sodium here. Sodium has that just one electron, and it wants to fly away, which means sodium is going to end up being an ion many times, which has a positive charge. So since sodium wants to fill its outer shell, and I heard somebody say one time, in fact it wasn't long ago, that sodium here and all these elements on this side, all these alkali metals and alkaline earth metals, want to be like the noble gases. The noble gases have all their outer electron shells filled, 2, 8, 8, and so on and so on. Since you have sodium here that has this plus charge, it's going to want to be like these noble gases. So it is quick to gobble up an electron. And from these halogens here, these halogens are quick to gobble up these electrons just because they have a negative charge. So whenever they gobble up an electron, it's often from one of these alkali metals here. So that's why you often have these alkali metals here, which bond with these halogens here, because that way the outer shells are going to be full, just like the noble gases are full here. And I'll just abbreviate noble gases. Well, anyway, that's called an ionic bond. An ionic bond is whenever you have those ions which form a compound. Now, I'll kind of give you a hint. Ionic bonding almost always occurs with at least one metal. At least one metal. And if, when in doubt, look to see whether these are metals or not. Are one of these metals right here? Let's look on the chart. Yes, you may remember that the metals are from the metalloid line over. So whenever you talk about sodium, there's a metal. So that could kind of give you a hint that sodium chloride, NaCl, is an ionic bond. And you see what happens here. This sodium has this one electron here that wants to fly away. And when it flies away, it is so easily accepted by chlorine or one of these halogens over there. And as a result, you have them a bond between them, which forms a completely different substance. And you may remember that NaCl is table salt. Now, you do have some other things that can happen in ionic bonds. It's not just the ones that lead or lose one electron. You have, for example, Ca. Ca happens to be right here. Now, all these in these alkaline earth metals like Ca, their shell is a little bit different. They have two electrons that are easy to fly out. These two electrons can bond with some of these over here. Sure, it could bond with one of these columns, but in this case, it's going to bond with this fluorine here. But notice the charge on the fluorine is going to be -1. So here's what happens. You have the two that want to fly away from calcium, which is what Ca is, and it's going to take one of them will go to one fluorine, and one of them will go to another fluorine, and that's when you have kind of like H2O. You have Ca and two of the fluorines right there. So the Ca with Ca, and I guess you can label it as 2+, and the fluorine ion is just a negative there. So as a result, it takes two fluorine ions to bond with one calcium ion, and it is going to form CaF2. That's what that will end up forming. Now, here's what happens with ionic compounds. They usually have strong bonds. Their melting points are usually very high. And the solids do not conduct electricity. So strong, high melting point, and solids don't conduct. Now, if you think about it, to have conducting of electricity, you normally have to have some kind of charge. Whenever all these things bond, they suddenly do not have a charge anymore. You have the +2 and the 2 negatives that cancel themselves out. So whenever calcium fluoride is bonded together, it's not conducting electricity. However, whenever they are melted, they do conduct electricity. Now let's talk a little bit about metallic bonds. You don't normally think much about metallic bonds, but metallic bonds have to do with all these transition metals right here. We're going to talk about zinc. These metals have kind of a different outer shells. These outer shells here are kind of made for bonding. You don't find much bonding that goes on with these transition metals here, but here's an example of where you do have a metallic bond. Notice it is zinc and zinc. Most of these metallic bonds bond with themselves. These elements often bond with themselves. So you have the +2 bonding with the -2, and since they can move freely from atom to atom, these charges, a metallic bond does conduct electricity as a solid. Solids conduct. And that is in the metallic bonds. So two differences between metallic bonds and ionic bonds. Metallic bonds are often the transition metals that are in the middle of the periodic table. They often bond with themselves. I guess this is three differences. And they conduct electricity as a solid. Hey, I hope you have learned a little bit about compounds.